this, please welcome Mr. Rahul with a huge round of applause.
So, hi, good noon everyone. So, since morning, all the speakers who spoke here have already touched upon artificial intelligence. I mean, in today's world, we can't think of our lives or our businesses without artificial intelligence. So, uh, we have many use cases which all the speakers before me have talked about, and I think after me also there would be speakers who will be talking on AI and ML. So, apart from these use cases, we need to see how really we can use our own data and how do we leverage our ERP data or our SaaS application data in supply chain and leverage AI and ML to get best out of it. So, let us go through agenda. So, we will quickly refresh what is AI ML and what are the other approaches. Then we will go to how do we apply AI in supply chain management. Later on, we will see a detailed or deep dive case wherein how do we integrate multiple aspects of data and external inputs like market intelligence and causal factors, and how do we get that data at one single place, and how do we run AI ML in agentic way, right? After that, we will have a use case on cost of compliance, and then we will have efficiency improvement model, and then we will have a small demo which we have done in-house. So, I am from, just repeating it, I am from JSW group. I take care of IT and digital solutions, right? So, let us start. So, before we go to next slide, let me take you back to the history. So, we as human invented our first machine very long back, and it was a mechanical lever, a simple mechanical lever. That's what we started with, and after that we always saw to it that how best we can make our machines useful, right? So, after inventing many machines, then we started thinking how do we make our machines more intelligent. So, artificial intelligence is not new. We have been doing this since many decades, right? It's only the invent of machine learning in 1990 to 2000, wherein AI got its required firepower through machine learning, right? So, when we started to think about our machines, how do we make it more intelligent, right? So, very important event happened in 1950 when Alan Turing made a paper and he published a framework to check and to know whether your machines are really intelligent. So, after when we came up with programmable machines or programmable computers, we really started getting into the logic that was a programmable, because earlier mechanical machines, they were not programmable. They had very limited scope of you can say intelligence or decision making. A simple case I can quote here is go no gauge. So, people who are there from the factory background or mechanical background, they understand what is go no gauge. That was a simple decision making tool, right? So, we are doing it since many decades, that how do we take help of machines to make certain kind of decision. But since mechanical machines were limited to a limited scope, it's only after that programmable machines in terms of computers came, that scope and the logic got expanded, and it became really programmable to handle a wide range of challenges, right? So, the real breakthrough came in 1996 and 97 when IBM Deep Blue, it won chess championship against Garry Kasparov. Actually, in 1996, the first match happened, which in 1996, in the first match, Garry Kasparov won the first game, right? Then IBM engineers made some changes in the logic, and on that game onwards, IBM Deep Blue started winning. So, that was a big milestone in terms of machine learning, and then machine learning started evolving in terms of neural network and decision trees. So the GPTs you see nowadays, that is GPT-3, GPT-4 or Chat GPT. Now recently on 14th April, that is day before yesterday, they came up with GPT 4.1 model. So GPT 4.1 model is more cheaper and more faster. So it is 26% cheaper, and if you utilize it properly, it can save you 80% of the cost. So point here is artificial intelligence is getting commoditized, right? It is going to become a commodity. The intelligence which you seek, that will become commodity, right? So let us start with it. So this is a kind of background. So as I said, we are trying to make the machine more intelligent, and in terms of supply chain, we already using these approaches. So apart from machine learning, what are the other approaches? So if you see, we started with hard-code manual rules, then we came to if-then logic, then we came to logical reasoning, then exploring possibilities, and recently before machine learning 1996 or 1990s, knowledge graphs were there, right? But why machine learning scores over all these earlier approaches? Because it can read non-structured data in terms of images, speeches, and videos, right? And it keeps learning by itself, and it keeps evolving. It is making your machines or system more and more intelligent. The more data you provide to machine learning, it will make your system more intelligent and more powerful. So this table, if we see how have we been using these approaches for supply chain, you can see this, right? I mean, we have been using this for supply chain. So we had simple rules earlier saying that if supplier delay is greater than 5 days, trigger alternative supplier. For inventory planning, we have rules on buffer stock, that is if and then logic. Then in logical reasoning, we have linear programming, linear optimization. So this is known to everyone. Whoever is using the modern supply chain tools or advanced planning tools, they know what is linear opt, and this is what is being used by production planning teams, right? Then we have optimization search in terms of transportation routes. We have control systems for supplier selection evaluation, and recently the knowledge graphs are being used for product hierarchies. What are my products? How can they be there be a hierarchy based on the knowledge graph? The data you feed to the machine, it will come out with that. But since supply chain, if you talk about supply chain, you have many processes within a supply chain. Let us say order to cash or procure to pay. Within this order to cash or procure to pay cycle also, there are many processes. So there is not a single artificial intelligent system which can work here. So what we need here is agents. So agent is nothing but an autonomous entity or autonomous program which has a specific goal or objective, and it does it uses power of AI. So it talks to, say, if you can connect your agent to GPT-4 or now GPT 4.1, it will do that intelligent work, get that intelligent work done from say GPT-4 or GPT 4.1, get that information, use that information, it gets into your own database or external source of data, and it executes the task which you want. So RPA, you can connect RPA here with the agents and get the desired output, right? So single agent for supply chain management will not work. You will need to have multiple agents working in a coordination so that you can have a goal-based system, right, which can take autonomous decision, which keeps learning from the external environment, and it can help you plan your supply chain. So that is how agentic AI comes into picture, and this is the way forward, right? So recently there was an interview of Satya Nadella. So Satya Nadella himself said that SaaS application, you can use SaaS application, you can generate your own data, you have a very rich set of data, whether it's your CRM system, say Salesforce, or whether you have your own supply chain planning system, whether it's a Kinaxis or Blue Yonder or O9, or you can have your ERP, legacy systems, you can have your MES factory data system. You get all this data on a single platform and then use multiple agents to achieve your goal. So they can be autonomous, they can be semi-autonomous, right? You can use NLP, you can use chatbots to interact with those agents and get the desired output. So let us see how can we do this for demand management. So this is what we are doing it at JSW. We have just started in-house and we are getting very good results out of it. So it's in a very nascent stage, but we are confident that we can leverage it in-house. So why in-house? Because we know our business, we know our data. So no one else can leverage our data other than ourselves. I mean, it's your business. If you are in any business, only you know the insights of the data. External partners can come and help you implement the technology, but it is you who you have to decide which data to be used, which people you need for that entire implementation, how are you going to handle that change management, right? So that's why in-house development has got its own importance. So this looks complex, but it is not. Let me help you with this. So here you see input. This is a natural language chatbot or say a UI wherein business can query. What can business query? It's limited to this model. So it can query about demand forecast. It can query about product segmentation. It can query about the customers which are high risk in terms of why their forecast accuracy is going down, why share of business is going down. So we call it high risk customers in terms of our business, right? So here, as I said, you are owner of your own data, so you have data from ERP or CRM, so you can have this data from SAP or say SFDC or Oracle, right, wherein you have typically invoice history or sales history, you have your customer master there, you have your product master there. So this is one set of data. Then this is another set of data, wherein at JSW we have Blue Yonder data. So we are using Blue Yonder SaaS application. So we have demand plan, supply plan, transportation plan available to promise data is there and order promising data is there. So, and the third set of data is market intelligence. So if you talk about manufacturing or industrial activity, so you can have this causal data, like what is the construction activity going on in a country, what is the import-export data, how is the auto sector doing, how is white sector goods doing, right? And then if you are doing any marketing campaign, what is the spend, time, season, what is the response of that marketing campaign. All that data you get on a particular warehouse. So in JSW's case, we are using Azure, so we get that data on our Azure data warehouse and we make a semantic table. Why semantic table? Because you only need to select a meaningful data which is required for your supply chain planning. You don't want to load entire data into your semantic table and you don't want to consume more tokens, right? You want your system to be efficient. So that's why semantic data table, which takes only relevant data which is required for supply chain planning or say supply chain insights, right? So this is the basic work and it takes some time to build this, and once business user query about anything regarding the demand forecast or high risk customer or say product segmentation, this is a agent or orchestration. So this is in a local machine, this is on Azure cloud, this is also on Azure cloud, this is your this can also be a partially cloud or partial your on-prem, and this is also outside intelligence. That can also be on cloud or some API from other websites, right? So this is on-prem. So we have 3 agents. One is orchestrator agent, who's kind of a manager who controls all the agents and govern the policy and directives, right? So this once business user do some kind of query, this agent decides what is it related to. Is it related to demand forecast or is it related to something else? And then it gives it to OpenAI service, whether it's a GPT-4 or GPT 4.0. It get back that it converts that NLP into a structured query. This agent decides whom to give this query, whether agent 2 or agent 3. In turn, this agent 2, agent 3 do their own task and send this query to this semantic table, which is holding all your supply chain data. In turn, they get a response from here. They again work on that response, give it back to the orchestrator or a manager agent, and this manager agent converts that data into a meaningful, say, tables or charts, and then it gives back to users in terms of output. And then we also get feedback from user, wherein whether you are satisfied with the system or not. That feedback is continuously assessed by this manager. So, and this all agents have their memory built in Azure. So they utilize that memory in terms of store that memory in terms of vectorized database, and every time a new query comes, first that memory is referred to, and then the task is executed. So this is overall a structure of agentic AI. And what are the benefits? So I think in previous session during a fireside chat, we already discussed how FMCG is doing demand management using AI and ML. So these are the use cases we already know, like periodic revision of product segmentation and identification of critical customers. Similarly, using the same kind of framework, you can have your inventory management, right? And you can achieve these goals in terms of supply chain planning. We have 2 minutes or 5 minutes? 1 minute, okay. So let me go through. So this is a classic case. I mean, every industry, every company face this, whether to expedite it or whether to face penalty. So traditional way of doing this is to use this table. If penalty is more than the cost of expediting, then let us expedite. If penalty is less, then let us delay it and notify the customer. But if you want to do it more AI way or ML way, then these are the kind of data you need to give input to your AI ML system, like inventory availability, customer profile, logistics cost, and then you have to model your AI system or agents accordingly. So this is just a schematic for how can you control your inventory across your channels. This is typically for FMCG company, right? You have multiple agents, a global coordinator agent, and then you have logistics agent, you have procurement agent which can talk to supplier through APIs. Then you have a stores agent which tracks inventory and gives signals, right? Let us have a quick demo. So this is we have developed in-house at JSW, right? So it is not very jazzy thing, but you can see the recorded. We have laptop with us here. If anyone is interested, you can connect with us later on. We can show this working to you. So this is on AI agent on advanced planning system, wherein we get order promising data and factory planner data. So order promising is done when new order comes in, then it goes to a factory, then factory plans by itself and it revises the promising date. So this is the query, and it is scanning the data, and it is also telling you how is the agent scanning entire database, right? So before giving it to business user, you can hide this. I mean, this is not relevant to business. This is just from the IT perspective, what are the tables and what are the queries it is going through. So we have queried from where do we get FP first commit date. So it is checking that semantic table and letting you know that these are the tables from where you can get the first commit date. So it came back with the answer saying that first commit date can be found in out FP plan table. So the person who doesn't know what is the database, he can also easily query this and get the answer. Now we are getting into a real business use case wherein we want to see the factory planner first commit date. So now it is fetching first commit date, factory planner first commit date for particular order. So it is saying 9th April is the factory planner first commit date. Now if you want to see what is the latest commit date, 1 minute it will be over. So this is what it is thinking. I mean, how to do it, how to execute it, that is what agent is thinking. It is going to GPT-4, it is getting that query back, it is again sending it to your semantic data table on Azure and getting this data. So this is the latest commit date. Latest commit date is what is today's revised factory planner date. So factory planner every day revises the date based on the real-time constraints or shutdown or breakdowns. And then we ask it what is the order promising date when order first came into or landed into the system. So this is in reality how this AI and ML work. This is a bit slower, but this can be made more faster and more jazzy. It's only that in-house development and our engineers are trying our hands at it. That's why it's not looking that jazzy and that fast. Okay, so any questions?
Sir, I would request you to please take the questions
Yeah,
during
sure,
the networking
sure,
session.
sure.
And
Thank
thank you
you
so much for your
much.
wonderful insights.